So, hi everybody. Once again, welcome to our weekly episode of YFTT, Yugabyte Friday Tech Talks. Today's talk is about triggers. I have with me Bryn. A lot of folks, a lot of you guys who have been regulars should know Bryn. He's already presented before. But anyways, Bryn is an expert from the Oracle world who's switched over to distributed SQL now. So Bryn, I don't know if you want to quickly introduce yourself.
Yes. I'm just going to move this last bloody slide.
All right, go for it. Go for it.
Following your last minute instructions here.
No worries, no worries. Take your time. Take your time.
And then I will do it.
All right.
I've suddenly lost it. Sorry about this.
No worries. Yeah.
Here it is. This is the slide in question. I just have to put it up here. Okay, there we are. Show the mutual. Okay, and then this slide has somehow got in the wrong order. I'll come to that when I come to it. Okay, then I'll start now then. Just for the time being, I'm going to leave my slide sorter on the left. And here we go. So I'm Bryn, and I think I've said this twice before. I'll say it one more time. If you want to know more about my dull life history, just look up Postgres Person of the Week, search in that, and there I am. It's an expanded version of what's in LinkedIn, but there are links to LinkedIn and Twitter and my blogs on the Yugabyte site. So that's quite enough of that. And we'll get this one down and then come back to the slides.
All right, you're not sharing your screen, Bryn, I think.
Oh, you should have said.
I didn't realize. It's fine. We were intro without it. It's fine.
That's your job to say.
That indeed is. All right, go for it now.
So share screen. Right. Oh, I think I've said this twice before. I'll say it one more time. If you want to know more about my dull history. No, that's not me. That's some recording of me.
All right, no worries.
Fix that, quick.
It's fixed, I think. Yeah, go for it.
Good. Okay, then. So you heard the title, Triggers Considered Harmful, ? Considered Harmful. Just a 2-second note on that. This has a long history. I didn't make it up. There's this whole thing about considered harmful to the nth degree. It was Dijkstra who first came up with it in connection with something computing, go-to statement considered harmful. That was in '68. You can look up his piece. It's quite nice reading how people were ranting about what these days we call best practices, even then. Back to the plot. Where are my slides gone? They're here. And then people argued about it a bit. By the way, he didn't coin the phrase, he got it off journalism, it's all over the place. And then some other guy, I don't think his piece is very well written actually, says he didn't like that idea, so he put it to the second power. And then a whole load of people started ranting on about it, and that's when it went up to the 3rd degree. So that's enough of that, and I just picked triggers to stick in there instead of go-to. And then I had to fight to have my title retained rather than having it chopped down to triggers considered harmful. What a world we live in. So then, this is just to put things in a more general context. You know this quote from Romeo and Juliet, what's in the name of Rose, blah, 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 blah. And the point is this. Everyone's heard of event handlers and callback routines, and I suppose they've heard of triggers too. What's an event handler? When you look it up on Wikipedia, it's a scheme that involves a callback routine, and the callback routine fires when some event takes place. And what's a callback routine? Slightly more general. It's a routine whose name you pass into some second routine as an argument so that that second routine can do what you want to happen, as you had written in the callback routine, when the main logic of the second routine gets to that spot. It's a sort of way to add in flexibility into an already existing program. And then a trigger, well, a trigger is a procedure or a routine or whatever you want to call it, that's invoked by the system, in this case, the RDBMS, when some event like inserting a row in a table or dropping an index or creating a table, any of that, whenever one of those events happens. So it's all part of the one way of seeing things, just with mixed vocabulary. When you create a trigger routine, to use the Wikipedia words, on a table, then you're declaring that the actions in that routine that you wrote will be carried out at the specified moment. And you have a way of expressing what that moment should be. Like, for example, before insert, and which flavor is it, for every row or for the whole statement? So a trigger does nothing more than declare a callback routine for a particular RDMS event. And if you start banging on about why triggers are harmful, you're in a way morally obliged to bang on about why the whole scheme of callbacks and event handlers and everything that permeates computer science is harmful. So then that's enough of that. Now, there are two flavors of trigger. There's what they call, very confusingly, since it's all about hanging on logic onto events, an event trigger versus a DML trigger. God knows how they came up with that word, but it's all over the RDBMS space. And by event trigger here, they mean the one that fires in response to some non-object specific in the whole system event, like creating a table or dropping a table or altering a table, that kind of stuff. In other RDBMSs, they have events for when a session starts, which is very useful, but strangely Postgres and therefore Yugabyte doesn't have one. So each has their own different metadata view, each has different syntax, and in Postgres, therefore YugabyteDB, the only things that you can hang an event trigger on are create, alter, drop, and if it's a drop that does some cascading, all the things that are triggered as a result of the cascade. Why, you might ask, why would you do that? Well, one case is auditing, but there are other approaches, and you'd be well advised to look at them before you roll your own. There's something, I can't go into it now, but there's a log statement configuration parameter, and there's even a PG audit native extension. But one thing that is interesting, I think, is in a production environment, if you want to be belt and braces sure that your whole design for the back end, the tables and the indexes and the procedures of the whole shooting match, if that's locked down, you can write a system trigger. It takes a super user to do this, but you can bargain to have that happen, that simply causes an error on any DDL. It doesn't have to be any DDL in the whole cluster. You can filter within the logic in various ways so that it'll just prevent DDL on your objects. Anyway, enough of that, no time to talk about that. Now on to the real thing, use cases for DML triggers. Interestingly, select, which you might think could be interesting to have some, intervention in, you can't do anything about that. There isn't one, never has been, no database has got one, it is what it is. But having said that, there are two classes of thing you can do, really. One is you can enforce a data rule of some sort simply by causing an exception when you have detected that the rule would be violated. Okay, and it's loosely speaking then, some form of constraint implementation. And certainly constraints that operate on the values within a single row, they're simple to write and they're safe in the sense there's no race condition discussion. But obviously, why would you do that when you've got real constraints, including function-based constraints? Perhaps a more interesting one is if you want to make a column value immutable for some reason. I don't think there's any declarative way of just marking a column as read-only, or I should say write once, read many, and you can do it trivially with a trigger. And then this is where it gets hard, but the trigger is the only solution. You can implement within table constraints, like you mustn't have fewer than 2 and more than 5 rows of a certain kind, meet some predicate, And they're tricky, not because the logic in itself seems hard to write, but because of race conditions stuff. I'll come back to that point if there's time. And then
before you go to the next point, right, Bryn,
yes.
like a couple of questions, right? So like right up, you make a point on can't fire a trigger on a select event, right? I'm curious, how do triggers in Postgres compare to, say, triggers in Oracle? I don't know much about Oracle, but do they have select triggers?
No. I tried to say that, but I rushed it. That's a universal thing.
A universal thing. Got it.
Yes.
Okay.
However, if you're a hard shell advocate, which I am, if you believe that the only way into the database should be through a stored procedure, well, you can implement what the hell you want right at the top level, and you can nominally then effectively get a trigger on whatever you want. And that would be very useful, for example, for starting a clock when some whole thing starts and finishing it when it ends, or even simply auditing, logging the various business functions that get called. So you can discover the ones that are popular and the ones that are seldom used, that kind of thing. So there's a way to get the functionality, but it only comes with a disciplined approach to everything. Otherwise, no, it's not Yugabyte, it's not Postgres, it's the world.
Makes sense. And there's another perhaps use case for the first bucket. I don't know, I'm just like voicing it out, and you can say, like, sometimes application logic might demand that you insert into the child table and then into the parent table inside a transaction for whatever reason. And in those cases, like, deferring the constraint or implementing it through a trigger might be another use case, right?
Well, the short answer is we come to exactly that use case if I get time, where I've implemented the whole thing. But you can't use a trigger there to make those side effects that you talked about happen. That's where the whole hard shell approach is. If you've got to first put the row into the details and blah, blah, and then associate with the master and do it in a deferred constraint regime, well, you do that, but that's classic methods, not the triggers. But the triggers come in useful in that picture, as I hope I'll have time to show you.
Okay, all right, let's go.
Yes. So moving on then, that was one class, just causing an error when you've detected something you don't like is about to happen and failing it. And the risks are, like I said, that you do it and it works, but you could have done it so much more simply, or that you do it and it seems to work, but you forgot to think about race conditions. And the short answer is perhaps all you need is to crank up to the serializable level. But that brings its own problems. So then the other class is implementing side effects. And this is where the debate rages hot. There's this general auditing that I mentioned, but there, my going in advice is, if you think you want something like that, look at native features for it. And if that's not what you need, then, like with the very dedicated employment history table, by all means, use a trigger. And the reason people don't like even that is because they think it's some sort of hidden functionality. You think you're doing one thing and other things happen. And if you're a hard shell guy, well, you might think, well, if I'm going to do that at the same time, I'll do that and blah, blah, all within the business transaction that I've implemented conventionally. So triggers are by no means mandated in that employment history case. Now then, that was that point. And then this one, this is the huge no-no. People have been doing this for years and people have been complaining about it for years. The general wisdom these days is don't denormalize. Stick to your strict third normal form and let the database deal with the joins, because otherwise it'll end in tears and possibly you'll even harm and not improve performance. So there we are then. Now, what I hope I can do now is talk about the mutual firing order of triggers, because there's various timing points, and I haven't really talked about that properly, and this will let me do that. So sadly, I got my slides slightly jumbled here, but nevertheless, I think I'm right again here now. We're going to need a trigger routine. So the basic architecture here is you've got a table, you want a trigger on it, you want some logic to happen. So you write the logic first and you do it in a function of a particular kind who returns a trigger. And when you do that, when you've said that, then within the function body, you have access to special variables. You just use these things without declaring them, and they tell you when the trigger fired. Was it an insert? Was it connected with after statement or before row, that kind of thing? And then you can reference the whole row as it was before and after whatever's going on through intrinsic or inbuilt record variables called old and new. And when you're done, you have to return what you want to. Some cases you return the new, if it's a before kind of thing. Sometimes you return the old, because you've got to return something and you didn't change anything, or it doesn't mean anything. So that's the basic architecture there. And then you attach it to a table like this. You create a table as a trigger. It's a kind of shim, a coupler between the table you want it to be on. You've got to give it a name, and then the function that you want to be invoked. These red words are the things you've got choice about. You can say before or after, and you can read what you got in the trigger routine. You can say if it's insert or delete or update or any two of them or all three. And then you can say if it's going to fire for every row or just for the whole statement. That's basically the degrees of freedom there. And if all these things here aren't enough for you, you can even use a variadic feature that this allows and put in any number of text arguments there and then inspect them inside your trigger function. The whole idea here is that you can use one function for many purposes. I hope you're with me there so far. So then now about the firing order. The firing order does matter, and I got this little experiment to look at it. And here I'm going to create the old, the old chestnut, the masters and details, because that's interesting, because there's the phenomenon of cascade delete. And if I have the whole thing larded up with all the triggers you could imagine, that's before and after the statement and row on each of masters and details, that's 8. Well, then I can just report, log into some log table what's going on, and then look afterwards, after the fact, to see what happens. There we are. I've said all that lot, 8 triggers in all. And then this is the table. No mysteries here, just so you know the names. They're called masters and details, obviously, and each has what I've informally called the payload column, the V in each. The rest is just plumbing that keeps it all together. And arranges that we've got this cascade going on. So then I'll have a single generic routine, which I've cunningly called generic trug, and I'm just going to detect what operation fired it and at what level it happened. And the reason for this is because I want to report this payload value, and I need to know if it's appropriate to report the old or the new, according to my context. If you're deleting something, there's no new to report. It's only old, for example. And then what's in the body? In the body, all I'm doing is writing a row into a table, which has got clearly a surrogate primary key, which will tell me the order. And I'm saying when, was it before or after? Was it insert, update, or delete on this particular occasion? What was the table in question? Because I've got 2 going on. And then what was the level? Is it row or statement? And when it's appropriate, what's my value of interest, the payload? And then when I've got to return, I've got to return the right thing. So I hope that was not too much of a rush. And then the 8 triggers, that's easy enough. I just use a trigger generator with this template, and all these dollar things here are the interesting variables, the table name, when it fires, and the level before. Sorry, the level is the statement or the row. The when is the before or after. And I build that into the name too. And then I just crank through the thing 8 times. And then I've got my 4 on the masters, 4 on the details. I got my whens, before, after, and I've got my levels, statement, row, statement, and so on. So all that lot is all the possibilities of the 8. I hope that was clear enough. And then one example is I've got this guy called Bill, and he's got these details, cup and saucer. And here's just a trivial query. I like to put it all on one row. It's easier to read that way. And that's my starting point. Clearly, when I delete Bill, cup and saucer are going to go too, and all these triggers will fire. And then here we are. I've put in a bit of white space, but this is the result. And what we're seeing here is that they interweave, maybe in an order you wouldn't have expected. The before delete at statement level fires for the master, because that's my statement. My statement is just delete from masters where he's equal to Bill. And then as soon as the statement thing has got going, the row thing fires for the row Bill in question. And then that's what kicks off the cascading already. So then my before delete on details statement level fires. So now we're on the details. And then the cup goes, and then the saucer goes. And before finishing off, we're in the details, we're back on the masters. And then the masters does his after row for Bill and his after statement. And then finally, we're back on details again. And, you know, it's the same antidote, cup and saucer are done after the delete and the after statement fires. Now, I needed to know that in this tricky use case I talk at the end. So it was very interesting to understand the firing order.
And Bryn, what happens if there is another trigger attached to the same row?
You mean simply now a simpler isolated case, only one table in discussion, but you've got lots of triggers on them?
Yeah, independent triggers, yes.
Yes. Well, you're in tricky territory here. It suggests a red light should be flashing, bad design, bad design. But there is a rule. In Oracle, it's one thing. In Postgres, it's a more transparent rule, but it's totally bollocks in the sense for doing something sensible. It's the alphabetical order of the trigger names. But clearly, you've thought things wrong here. If you think that you need all those triggers, you should combine their actions into one trigger.
No, I'm with you. It was more of academic interest, but yeah.
Well, then you've got the academic answer, alphabetical order, if it makes sense to you.
Got it. I wouldn't have thought, but thanks.
At least you can rely on that. In Oracle, you can't. It's on the order of this internal GUID, so to speak. And there, it's different after export and import, and God knows what. There, they just, in a sense, tell you it's random. Okay, so that was that. So there is now a demo. I'll show you quick, but I'll just say, I did promise to talk about the fact that there's internal triggers and you can't get away from them. And it is quite interesting. I've just created a little temporary view here. That's a nice feature of Postgres, by the way. Oracle doesn't have it. It just lasts for the lifetime of the session, and it lets you write all sorts of ad hoc queries quite usefully without, you know, tons of long code. You just define something once and then refer to it. And what I'm doing here is I'm looking in this thing called PG class, which is where tables are, and PG trigger, which is where the triggers are, and joining them up so I can get the names right. That's not rocket science. I'm looking at the triggers whose flag in the PG trigger thing are called internal. That's a nice thing. You don't have to go where it equals Y or something stupid. It's so nice to have a Boolean data type. And then there's this function available who gets the whole definition. And I've listed it out here for just one of them. And you can see it's got the system generated name, and it's on the table masters, and its whole definition starts off with create constraint, blah, 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 blah. And all I've done following that is say, well, I want to look at that and I want it a bit more readable. So I'm getting rid of all this boilerplate text that I don't need to see. And I'm getting rid of that too. And, you know, filtering out stuff that's redundant. This is what I'm left with. I've got an after delete and after insert, so on. Some of them are masters and some of them are details. And you can see roughly what they're doing. One of them is looking after the cascade delete, and one of them is checking that the rule holds, and on and on and on and on. And I'm just going to see if I can squeeze in a academic point here now, and that is these are so-called constraint triggers. They're an interesting phenomenon. Postgres supports them. Yugabyte doesn't yet. But the word on the street is that they are just dangerous and you shouldn't go near them with a barge pole. So I'm not exactly crying at the moment that Yugabyte hasn't got support for them. And after a long debate on that experts list, I finally was persuaded that the only way to write one of these constraint triggers safely is to write the function in C, and in C, you dig down under the surface and you look at the before image and the after image and all that stuff. And that's how you manage to avoid all this race condition, need for serialization stuff. And if you've ever wondered, that is how foreign keys manage to work at the ordinary vanilla read committed level. You'd think, if you thought it through in a sense, when you first started to understand about serialization and all that stuff, that foreign key constraints would work only at the serializable level. But the reason they work well in the vanilla level is exactly that the implementation is done in this cunning under the covers way. It's like a very special case, localized targeted case of serialization itself. So then that's a word of advice for you there. You know they're there. Don't shed any tears that Yugabyte hasn't got them yet. Moving on then, are they harmful? Well, how can they possibly be harmful? The only way you can think that they're harmful is if you think that foreign keys are harmful. Of course, some people do think they're harmful, but they are regarded most generally as total crazies, and we can write them off. And what I'm saying here is, if foreign keys are benign, well, triggers are benign too. So there we have it, my thesis. So there's another use case now. I maybe will just cram over to the demos and show you something very, very quickly then. If I go on the pink, this is where the Zoom stuff drives me mad. I can't see the controls because my Zoom thing is covering up anything of important. Here I'm on the place where I've got the firing order demo code all set up. You know, it's the usual stuff. I've got the helpers who log into the table. I've got the tables being created, the triggers being created, the function and then the triggers themselves, and then some code for doing inserts and updates. And then I got my tests, and very straightforward. So I'll just run it in Yugabyte. And this script here, YB, does nothing other than run the whole shooting match and spool it to a file. There you are. That's my way of doing things. Sorry, nothing to see. Nothing to see means nothing went wrong. I like that. Then I'll look at what I wrote and see if it's what I want. Now I'll do the same in Postgres. It's naturally, for the well-known reasons, slightly quicker, but you can hardly say that the YugabyteDB, the YSQL was slow. And then I'll just zoom over to my differ. And here I am where I might make sure I'm on triggers. I'm on the firing order. I'm on the output. I'll pick the YB file and I'll pick the PG file, and they're identical. Okay. So the only point there is the one we've made many, many times. When we say we're Yugabyte compatible, we really, really, really mean it.
Postgres compatible, yeah.
Yes, Postgres compatible. I'm sorry. One day they'll be saying that Postgres is fully YugabyteDB compatible, but we haven't quite got there yet. I'm ahead of the game. So now we'll move on to another case where my title slide got jumbled away, and we're going to talk about the use case where you insist that a column has only lowercase values. And I'll show you a method that certainly works, and it's highly disapproved of. Let me say that up front. I've got a table, it's got its V, and then here's my trigger function, and all it does is insist that the value is going to be the lowercase of whatever that anybody said. And this is what a trigger lets you do with this new thing. You can look at what came in and say, I don't like that. I'm going to change it. I'm going to rewrite it. And this is what goes into the table. And it's exactly that subversion of intent that some people complain about. And then the trigger, I'm going to do it before insert or update, because before is when I've got a chance to make the change. I can't make any change afterwards. It certainly works. You know, I insert a big cat and a dog, and then I update the dog to make him frog with a big F. What am I left with? All lowercase. Well, some people would say that's bloody rubbish. You know, I said that and I haven't got what I wanted. That's why the harmful thing comes.
Yeah, but if it's something like an email address, for example, it may be okay. But yeah, it's got to be.
Well, this is exactly the same. There's no difference. It's the same debate, and people would say no. Okay. And this is the approved approach. Rather, you just check that the value that goes in conforms to your rules, and you let it be someone else's responsibility to make sure. And if this was a full-on hard shell thing, and someone sent me a wrong cat, I would just complain, you sent me the wrong stuff, go back to UI and do it there, you know? And modern UIs, if the intention is that it be lowercase, just lowercase it as you're doing it, so you see what happens.
Fair point, yeah, fair point.
And it's the same with emails too, you know? You shouldn't get out of the box where you're typing it in while it's still wrong.
Yeah.
And
fair.
Down here, then, you simply want to check, not coerce. That's the morality of it. And I'm just, you know, on the side of the moralists who think that these side effects are bad. So then, you can use a trigger to do that, of course. I've called it silly. You'll see why in a minute. All I'm doing is slightly recasting it. I say, if it's not already all lowercase, well, I don't like that. I'm going to raise an exception. Okay. And this is the paradigm of a trigger that's enforcing a rule. You check a few things and you raise an exception if you didn't like what you got. And here I'm again doing it before, because I don't want to let it go on and on and on and find the harm only later. And then, of course, what happens here is at the moment I try to insert that, I get it wrong, and on and on and on. Why is it silly? Well, you don't need a trigger at all. And here we have it. This is the most obvious way to do it. I'm just saying there's a constraint. I've given it a name, and it's checking that. Who needs a trigger for that? And then taking it one point further, some of these conditions that you want to check are hard to do in a single SQL expression. And in my hands, the canonical example is where you want to check that a JSON document conforms to its JSON schema. That involves all sorts of scanning things and looping in, you know, procedural code and so on, all of which you can perfectly easily do and encapsulate in a function and hang on a constraint. And far better is it to do that this way than in a trigger function. Now, if you're coming from Oracle, that might not occur to you, because Oracle doesn't let you have constraints on functions. It's some moral stance, which clearly doesn't make any sense because you can achieve the same with the trigger. But I don't know if the lock-in merchant is here today, but if you think lock-in is bad, you're never going to use a constraint-based function in Postgres and Yugabyte because Oracle hasn't got them. I think that's a crazy way of thinking. So that was that.
1 second, Bryn. Hey, folks, we're at the hour, but you know there's still a few more interesting examples that Bryn has, so we're probably going to keep going. Hopefully, you guys can continue along as well. Yeah. So go ahead, Bryn. Yeah.
Yes, I can round off quite quickly and then leave it open as to whether I do any demo. So we've talked about that there too, and then. Final twist on this is Postgres and therefore YSQL have got a domain idea, which Oracle database doesn't have. And if you think you're going to have lots of lowercase columns all over the place, you create a domain once and you put the same constraint on the domain rather than on an individual column, and you set it up like that. Bob's your uncle. All right then. So this is now the use case, is enforcing the famous mandatory one-to-one rule. And this is where we get into hard territory suddenly. And this is where some of you might feel you've had enough, but I've got as much here as anyone's got an appetite for. But keeping it at high level first, the rule is simply stated. Each master must have at least one details row. And it's tricky because of the possibility of race conditions. You've got to enforce it when you insert a new master. That's easy enough because no one else can see the to-be new pair until you commit, and you can make sure conventionally that both halves of the pair are in place. But when you delete a details row, I'm sure you can see that each of two concurrent sessions may delete a whole shed load of details rows, leaving one only, which they think is okay, but each of them leaves a different one. And then if you go about this checking naively, both will pass the test. And then when both have committed, you'll be left with the rule violated because there's no details. Yeah. So that's the thing. And if you go about it in that naive way, you have to use the serializable level. Now, if you do, well, fair enough. It all works, except it's deceptive as well. This is simple enough. You just say, have I got the condition I'm after? If I haven't, I raise an exception. Nothing could be easier than that. And you do it in both places. You do it on the masters, and then you do it on the details. Now, what's this funny little gray stuff? I thought I had a nice little demo here until I really thought. And then when I ran it, I found, oh, it all worked fine in many cases. But when I tried the ordinary cascade delete, it was inhibited because of these checks. And that all goes back to what order various things happen in. And the triggers were, if you like, firing prematurely and complaining before the full cascade delete had taken its effect. By the time you got nothing, there's no rule to check. But, timing gets in your way here. Not the timing that's got to do with race conditions, just the arc of time in one session. And that's why when this whole thing here suddenly goes from something simple to a whole Baroque complexity. Not that complex. I wrote it and it works perfectly splendidly in both Postgres and YSQL. I won't show you the demo unless we have time, but this is what I said. And the trick is you have to find the right little opening in one trigger, a before delete on masters, and set a flag. How do you set a flag? Where do you put a flag? This is where package state would be so useful, and we haven't got it, but you can use a temporary table, and then you have to unset the flag at the right moment, which is after, by the time you finish doing everything, which is the one in the details. So this is where knowing that firing order that I talked about before works. And then, so I could show you that. And as I say, it's a nuisance. So there's another way, and I'll sketch this and then I'm done. You can find this on the web, but you only find the little top of the tip of the iceberg. You set up a masters and details table with a mutual foreign key constraint. You see the symmetry here. Each has got a constraint down the bottom, I put them here, going to the other one. And that means that one of the details rows has a special status. It's the parent for its own master. And that certainly makes the rule inviolable. It's perfect, and you don't have to worry about race conditions because it's all done by native functionality that somehow they managed to get right, even at the junior isolation level. But there's a catch there, and it's this. What if you want to delete that special row, who is the parent of its own child, so to speak? Yeah. And I say that's easy. You've got to twizzle around. You've got to look at what remains and appoint one of the survivors to be the new special detail, and it's as simple as that in concept. And I'm here saying it's all in a day's work for someone whose job is working inside the database. I humbly offer the notion that if you're a UI specialist and thinking about all sorts of things and coordinating with other microservices and who knows what, you're not going to have the bandwidth to sort through all this lot. And you'll take the other approach, which is arguably the best to this use case, which is go back to the functional spec and say, we don't want that, cross it out of the functional spec. And that's not as flippant as it sounds. But anyway, that's the logic. You can see it's not, like you can't read that, but you can see it's not overwhelming in its size. And interestingly, you need only a single trigger in this regime. To make the other one work, you needed 4. 2 more if you insist on some immutability for the important columns. So here's the summary. I think, though I could have done this so much better with twice the time, that I showed you cases where they're harmful. That's to some extent a religious stance, but I'm of the stance that those side effects are harmful, unless it's something really defensible like the job histories. I showed you cases where, well, certainly a trigger would work, and if you're in Oracle, that's all you've got, but it's far better to use a function-based constraint and maybe to attach it to a domain. And I say only function-based constraint because I'm assuming that the rules are so complicated that they'd be hard to explain in SQL. If you can explain them, I mean, state them, declare them in SQL, well, you don't need the function-based constraint, obviously. And then I've shown you cases where using a trigger is essential, never mind the internal trigger now, that was its own little point. But the mandatory one-to-one thing, if you believe that, and there are other cases in that general class, well, the trigger is the only way you'll get your rule enforced. The only other approach is to declare in your functional spec that you don't like the rule and get on with your life. And then I think I'm going to claim it's true that those examples that I sketched out where you really found that a trigger was the only way, well, they absolutely show that that stance that triggers are considered harmful is without doubt a harmful stance. So there you have it. I could, if anyone's interested, move on and show you some demos, but you must decide if that's worth the extra time.
I think we're probably out of time. So maybe, Bryn, we just, as a part of in the LinkedIn thing, just share your GitHub repo. And that might be useful for folks, I feel. Because I felt like the slides were pretty clear in explaining, and I know you just like
good. Let's leave it at that.
Yeah. All right, cool. I don't see any questions, so maybe we can call it a wrap. Thank you, folks, for attending. You can always ask Bryn on the LinkedIn comment box itself, or you can join our community Slack, yugabyte.com/Slack. It's just showing up on the slides, YFTT channel. And Bryn or somebody else from the Yugabyte side will answer any questions you have. And thanks, everybody, for attending. See you guys next week, same place, same time.
Bye now. Thank you.